Thank you. You joined us today. Last talk, great conference. Many people are tired, probably because of the party yesterday. But still, I would start with start. So, welcome to the talk, Beyond DDD 101. Before we actually start, I love that this time, domain-driven design, CQRS, all these patterns, it's kind of multiple talks are about this, right? Just the question who's been to the talk yesterday of Lutz, actually, on events. Lutz was there, that's okay. Who's been to the Google guys on orchestration versus choreography? Okay, also some few. Okay, so let's do it. So who are we? I'm Simon. That's my friend and colleague Jan.
Hi.
We are both consultants at Holisticon. We are passionate backend developers, software architects. We do a lot of stuff. Especially we are kind of passion orchestrators, process automators, and so on. But today we want to talk a little bit different subject: domain-driven design, CQRS, Axon Framework, Spring, Kotlin, Java. That's our universe. Some words about Holisticon. So what's Holisticon? It's IT consulting. So we are not building any product. We are working for our customers. We have about 70 people, 3 offices founded in Hamburg. Then we have one in Hanover and Kiel. Pretty cool crew. We won this Kununu Best Employer 2022. So this is, I think, the only thing why we now can put it on the slide. Of course, we're hiring as everyone. And yeah, we do, as you see, a lot of stuff, right? So yeah, we do business process automation, but we also do software architecture and development. And we do smart data, UX, UI, security. And of course, we're doing agile and organization development. So if there is something for you, get contact to us and then we'll speak. Why we decided to talk here? Yeah, actually we are doing some projects with practical application of domain-driven design, CQRS, yes. And we are building some large-scale applications running on JVM. And as usual, we have this culture of failing, and we are failing. And we wanted to share some experiences with you. So probably maybe some takeaways for you not to fail in the same places where we did. Before we actually do this, we still need some foundation, because I can't assume that every acronym written on a slide is well known, well understood, just to a little bit set up the stage. So let's start domain-driven design. Probably most people have seen the cover of this book. Some of the people maybe have read this book. So what is it? It's a set of principles for implementing complex systems. And since these are principles, so they don't start on the implementation phase, they start way before in the requirement engineering. And there is a lot of techniques in the requirement engineering to understand what problem you are actually facing, what are you doing. So there is this domain modeling techniques, there is strategic design, then this identification of bounded context, which has some kind of solution islands in your architecture and then final system. There is this context mapping and all this stuff. And then there are also some practical stuff for tactical design and fine-grained architecture. A lot of design patterns, and most people know these design patterns without have been ever reading this book. For us, we are currently looking on some kind of distributed systems. So we picked some of them just to name them, to say, okay, this is what we just need to understand, to lead you through the talk and through these ideas. So if some systems cooperate, or basically are part of our system, there are different ways how they could cooperate. And the easiest way, they are not. And this is called separate ways. So you have just two systems and they're just there and they're not speaking to each other. And sometimes they need to cooperate just to achieve a common goal, right? So we speak about these partnerships. So they're both interested in achieving a common goal. And then there are relationships between these systems. So here you see, basically, this is what Eric Evans says. It's all about these bounded context relationships. But if we are in this microservice world, we can approximately map it to something like microservices, which is not an equal sign, right? But there is this idea of upstream-downstream dependency. So what is an upstream? An upstream says I can't succeed without the other. And the downstream means I actually need to communicate with the other to succeed, right? So this is kind of, they're not really equal. And yeah, how do they communicate? So the upstream usually define the semantics of something, like of messages or API or whatever, and this got published, okay? And then as a downstream, I can just accept this, so this published language, and use it. And sometimes I don't want this because I have my own semantics, so I have kind of a mapping of the semantic model of one system to my semantic model of my system. So we speak about this anti-corruption layer then, where we just actually map semantics, right? And on a technical level, you have all this kind of patterns, value object, entity, aggregate, aggregate root. This is, which is well known, for example, for Spring Framework. You have these factories, repositories. So this is kind of common sense, right? The term domain event, this is actually from that book. And yeah, everyone who missed the talk yesterday from those, shame on you, actually, because he was explaining it in a very well matter. What does it mean, this domain event? This small diagram on this side, this is actually one of these diagrams proposed for the context mapping. So there you have this bounded context, and then you can specify this relationship. You see the small u and the small d. This is the upstream downstream. And this is basically done in the requirement phase. So you say, okay, actually in transition between requirements and implementation, you do something like this to identify your parts and dependencies. So let's move on. If we speak about complexity and complex systems, I mean, why should we apply some kind of additional principles? Sometimes things get very complicated. And there was another guy, it's actually not Eric Evans, but it's Greg Young, who said sometimes to make it more easier to handle, you should actually split up your domain model in parts. And this is nothing new, right? So we're continuously splitting up stuff in parts. But he said, you know, the principle how you should split it up is actually to split to command and query side. And what does it mean? That means that this command part is actually only for kind of write requests or changing requests. So if you have an intent to change the state of the system, you are speaking with the command side. And if you will just want to get some information, you are speaking with the query side. And by doing this, so why should it help? So the first question is why it's a good idea. You're not going to do any compromises on representation of your domain model. Because sometimes, especially there are systems which are very tending to do so, you have this problem of, you know, I have the uniform data model and somehow it doesn't fit. And then you start to say, yeah, for the command side, I need this relationship. For the query side, I want to query something else. So just do it separately. Okay, and then you can, if you do it separately, you can scale it out independently, especially if you have asynchronous load, like people from outside are querying your model much more often than you're changing your system, for example. Event sourcing, for all of you who haven't been there yesterday, again, wonderful thing. It's a persistence strategy. So inside of my system, I can decide how I store my system state, and I can either store the state itself for example, relational database, or I can store the changes. So I just basically every change I do in the system I store, and then I can deduce my current state from these changes. So this is event sourcing. And there is a smart idea to combine these two ideas in one, and then we get to this acronym CQRS, which is the command side that is accepting commands needs somehow to communicate the changes to the query side. So let's use the main event for this, and let's store these domain events and use as the primary element for event sourcing, right? So this is kind of the CQRS in 2 minutes. Let's move on. There are different architecture patterns or styles, flavors out there, right? We started very long time ago with tier architecture, and in context of microservices, you sometimes or even often see this onion architecture, which is the idea that your center of the application should be your pure business domain logic, and this is kind of encapsulated and should be free of some additional artifacts having to do with technology. And then you have additional rings outside going towards that kind of technology, right? So, and it's onion because this is like rings inside one of the other. If you want to interact with the system, you usually have something passing requests in, like people are calling it driving or primary adapter, for example, the REST controller or something like this. Then you access a port of the application, which is usually an API endpoint. And then it goes into the domain core, you do some calculations, and then sometimes the domain model needs to do something that can't perform itself. So it relies on additional stuff which is outside of the core. And this is where you again access the port, and then you go out to this driven adapter. So for people who are doing Spring, it's kind of very easy. REST controller, some application logic, repository. A repository is actually implemented by Spring, and this is the classical driven adapter for, kind of Spring application. I think kind of understood, right? What is this Axon Framework? Who knows actually what Axon Framework is? Wow. 4 people. Okay, we should maybe spend a little bit time on this. So it's a free and open source framework written in Java for implementing systems following domain-driven design, CQRS. So designed exactly for this purpose. Integrates well with Spring Boot and everything like this. It has some ideas in it. One of them is it has an explicit message concept. So, and it uses this messaging for internal decoupling of components inside of the resulting system. Why there are 3 buses? Or 3 buses for decoupling and 3 types of messages. There is a command message, there is an event message, and there is a query message. Command, thank you, Lutz, as explained yesterday. So it's an addressed intent of change. They may fail, so we can want to change a state of the system, and the system may say it's not a valid change, I don't accept it. Commands are always unicast, so they are addressed to a single destination. Event is a fact in history. Something has changed, this is just published, and there might be event handlers who are interested in this change, and then they just receive it, so it's broadcast. And a query is a request for data. It may have a result, and it's a multicast. So usually you may ask one destination, but you may also say, tell me some information, I collect the data, what do I get back? It uses domain model segregation, so you have some facilities and help to do this command and query segregation. And it allows you to do event sourcing pretty easy because it provides you different event stores you can use for persistence. And you connect this to relational database or Mongo database, or they have their own, which is part of the Axon server, and so on. And another nice feature, separation of business logic from configuration. So if you do it according to the blueprint, you can later on change the configuration of the application and distribute differently. For example, use location transparency for stuff and so on. So they have pretty decent documentation, and they have this slide of kind of possible architecture, very simplified using Axon Framework. So imagine now this knowledge of Onion helps you a little bit. You have a driving adapter, which is the UI. You want to change something in the system, you're sending a command, and there is a command handling component that is responsible for this. So this will load the state of the command side. So the command model, it can use event sourcing for this. If it accepts the command, you get the result the command has been accepted, but you don't see the change yet. This change is propagated using an event, and there are some event handling components who receive these events, they change the query part, and then you can query this, right? And this connection between the command part and the query part is, of course, eventually consistent. So you don't get it immediately, but you get it eventually, right? And there are many use cases where this is completely accepted and okay. And Axon guys were building this framework with some ideas in mind. Especially they thought how you actually build system evolutionary. So they start build these components of your systems. So accept this kind of segregation, build the components of the systems, and use these buses for communication between the components. So loose coupling inside of the one system architecture. So start with the monolith, which is don't distribute on day one, but begin with a with a single system, and then later on demand you can distribute along the buses. Okay, so this is the later on configuration without changing the business logic. And then if you have some demand on performance, for example, you can scale out projections. You can build new projections later because you're using event sourcing and all this stuff. Or you can change the infrastructure, how you distribute stuff. So this is kind of what they had in mind. But again, for single context, okay? So for one system. So let's try to understand how they really understood the Onion architecture style. So again, we have this idea of our application, and we have some domain core inside, right? So again, CQRS, so splitting up in command part, we will receive commands using this this command bus, and the query part, the query model, and there we will receive queries from the query bus. So we have these buses explicitly. And so if we have a driving adapter, like a REST adapter or so, then there is a small gateway that allows you to send command over to this bus. And then the command model will eventually load some data to get the current state of the model. And it will use some aggregate repository, which is then located as a secondary adapter in the infrastructure layer. And then by doing this, if command is accepted, it will communicate the change using the event bus. This is kind of clear. Inside of this, of the Axon framework, the event bus is, of course, interconnected. So you will also get this event delivered to the query side. And query side is an event handling component. It can modify its state, store it again, maybe in some kind of projection. And then you can query it using some kind of a query adapter from your REST interface. And some changes might be not only interesting for this system, but maybe for some other system. So you might emit additional events. And to a little bit separate them, just to know what we are speaking about, we call them pivotal events, because now we're speaking about leaving the bounded context and the boundary of the system. So not to mix up with what kind of event it is. There is also a notion of milestone events sometimes, but we stick on this pivotal. And of course, there might be pivotal events coming from outside, again, driving your application. So you can fill up the query model with some result from outside. And there are more more event handling components like Saga, for example, and they do something like reacting on events and modifying some state internal, which means sending commands using the internal bus, or sending queries, or sending commands to the outside world, right? And sending queries. Okay, so kind of pretty obvious, right? Very easy.
Simon, let me stop you right there. Sorry. I mean, it's Friday, it's after 5 p.m. The people had a party yesterday, to mention. I think we made 2 promises to you today. First one was DDD 101, kind of foundation, common level of understanding, but we also promised you that we would share some best practices, experiences that we made working with distributed context. So let's clean up a little. This inside stuff, how our context interacts, how many microservices are part of my context. Just put this away for now. We're just looking at the context from the outside, and we minimize this to a simple building block where we have a command query model and this Saga, somehow distributed state management component inside. And we have the 3 buses we use. The patterns and practices I talk about right now, consider them not to be Axon specific, but keep in mind that the Axon semantics, so the event bud is fire forget, the command can fail, and the query will return a response. This is an important concept for the following patterns, but not using the Axon server or framework in particular, but we made our experiences using the Axon framework and server. Okay, we do not have just 1 building block, we have 2 building blocks, of course, we want to interact. And what we did, based on our project experience, we derived some patterns. Good thing you already learned something. This is the first pattern. Yeah? It's separate ways, just 2 contexts sharing nothing, know nothing about each other, and working separately. But this is not so exciting, so the question is, what patterns do we need when we want to make them collaborate and interact? We kept the same split between query and command side and derived 3 models, 3 patterns for each side. Kind of a disclaimer, patterns, we try to build an abstract model and name it so we can discuss it. Of course, it's all those patterns interact, and you might find some patterns that look similar, and if you try to analyze what is this now, maybe it's both, maybe we will end up with 8, maybe we will end up with 4 later. This is some intermediate research. Let's start with the first one for the query side. This is pretty easy. It's a master data query, how we called it. This you are, remember the semantics Simon told you about. We are on the downstream side, so on the right side we have an upstream component. This is just working. It doesn't need us to fulfill its purpose. We are on the left side downstream, and we want some information. The good thing is we just ask and we get this information back. Perfect. If you use the Axon server for this, in the middle you have the cloud, and this is location transparent, so downstream doesn't have to know which upstream component will answer the query. It just knows that it will get a response. Okay, benefits, challenges. This is how we structure these patterns. I mean, it's simple, right? It's basically a REST GET with all the implications a REST GET has. So you have on the downside a runtime dependency, so the system I query has to be up and running when I want a result. You have caching issues, so when I ask for customer information at 8 o'clock, can I still use this information at 9 o'clock? Do I have to requery all these things? But it's still a good pattern because you avoid data redundancy, which we found out in our projects is especially relevant when you have personal sensible data, GDPR relevant information. So I only query for customer name and telephone number when I really need it. And outside of this context, if we consider the right side to be the customer service, I just work with IDs and stuff. And I do not have to interpret all this inside eventing how often did you move? Did you marry and change your last name, whatever? So this is, some people don't like it. I regularly discuss it with my colleagues, but I like this pattern because it's simple. We want, though, it's a trap. It's so simple that the other teams, once they know that you are implementing on the right side a system that can just be queried, they will try to move their, how do I get my data and where do I get it from, to your side. And you have to be careful not to try to provide queries for data you don't own. So do not collect something from other services just to provide it for someone else if you're not interested in this information yourself. And yeah, to the next one, I mentioned the caching aspect. Of course, caching can be avoided by cache invalidation. So in this case, the upstream who owns the query model notifies me, and I have some change. This is basically just order changed ID 17, and then I make the round trip and do the query. Often discussed, if you send me this event anyway, why do you just send me the whole data I need? But this is again a trap, because then you have this one event, new customer address, several services interested in different fields of this event, and you end up either creating many specialized query models or not publishing one event, but many special events. One thing to be careful about, what I call the query avalanche. If you build a system, you have this cycle loop. We had implemented this once where the upstream side, who doesn't know and doesn't care about what we do on the downstream side, did a mass update, some batch operation overnight. This led to millions of, here's a data change event, which led to millions of queries on our side to the origin of this event, give me this new information. So both systems just got heavy load, and it took hours until this calmed down again. Just beware of this. Next thing, this is what you typically address when you talk about event-driven architectures. You have a state change in the upstream model. I propagate an event, and I use this event to update my own query model. This is also a perfect pattern to collect data from different contexts. If I build a reporting system or interested in more than just one origin of information, it's completely decoupled. And the problem here as well, these events are your API, and if you deal with many systems, what do you put in this event? Probably a good approach is to have some basic information in this notification from the previous slide, and then allow people to ask for more data. We're running a bit out of time, so we come to the command side now. First thing, again, the easiest one, event-driven. As Lutz mentioned yesterday, I have a state change on the left side, I fire an event, and this leads to a state change on the right side. The event handler on the downstream side must never fail, so I just have to accept whatever you give me. But it's simple, it's completely decoupled. And the problem you have here is a development team that this Saga component on the right side, which handles an event, creates a command, which propagates an event. This is not nice to build because you do a lot of mapping and POJO operations that are not that interesting to build. The next is that I, on the downstream side, need the upstream service as part of working on my purpose. But I know that the upstream side just does me a favor because it normally would operate without me. So when I send a command, I have only an intermediate state change on my side, and only after I get confirmation from the upstream side, I handle this for the internal command bus and have a state change here. Good thing, we built this for failure. So we have a decoupled system, and the Saga takes care of the state distribution problem. As always, I have to do compensation when some other services fail. And you can imagine that this is getting more complex when you're not dealing with just one external context, but many, because you have to consider this whole A fails, B doesn't fail, how do I do compensation right now? Which leads us to the last pattern we have today, which is the external orchestrator. You address this problem of complexity when you have changes in multiple systems. So you say both systems on left and right basically are separate ways, and you build a higher use case with a system in the middle where you say, I take care of the operation. Typical example for this is the two-phase commit transaction, with where you book an hotel, flight and everything. So left and right, car, hotel and plane. I send a command, get a response, send another command, get a response. And when both are successful, I complete and have the state change on both sides. When anything fails, I have to do the compensation for the according systems. And yeah, what we typically do, someone mentioned that we come from process automation. This system in the middle is typically a BPMN process and some process engine running. I think I caught up some minutes, which gives us time for some key takeaways.
Yeah. So what I've seen now that we used a lot of these dependencies, basically context mapping, this relationship mapping, which comes actually from strategic design. So this is the phase where you say, oh, now I'm here to understand the problem, and then there are some steps, and then you draw these circles, and then you connect them, and you say, yeah, that's good enough, let's move forward, right? But in the end, you see, we showed you several patterns where it actually depends on what is the U and what is the D, what kind of coupling you want between them. And the answer to this is always inside of your domain. It's never a technical decision. You can drill down to technical decision in some special cases, but a good advice is actually to look to the domain problem and to the domain problem space to understand this relationship for real. And it looks so silly, it's only a U and a D there, right? But there are hours of workshops to understand this relationship. So you need to speak with your domain knowledge or with your domain experts to gain this knowledge. Who is driving it? Who is responsible for this? Can I succeed without the other, and so on? It's not trivial, and it's a very important step actually in the actual modeling in the very beginning. And you know, let's start hacking, and then you sit in front of this and say, like, should we query, or should they emit an event? So how do we build this? So do proper context mapping. This helps a lot to understand what you're building. For CQRS, yes. Doesn't matter if you use Axon Framework or you don't. These command event query abstraction are very important because you have different semantics of messages, and you can optimize for this. It helps a lot, really. If you use or you're building system on JVM, have a look on Axon Framework. Axon Framework is free. Axon Server is not, but there is a free version. But if you want to run for production, probably you should pay money for that. Still have a look. Very interesting framework. Practically, don't distribute ideally at all. Build for the distribution later. Okay, so start with the modulates, and then build evolutionary, and then decide what parts you need to distribute. Don't do this. Let's invest in infrastructure in the first 5 sprints and create a large setup. Miss something from the takeaways?
I think what's important with this upstream downstream, I think I forgot to mention this. This is Conway's law is hitting this completely, because you can define your context and you can define up and downstream if your team structure doesn't match this. Like I said, I ended up being part of a team that built query models for other teams just because we opened the door a tiny bit. I think it's important to analyze this context map and then derive the team's building the context based on that, or not look how your organization is structured and then build the context after that.
Okay, that was the last slide. So if you want to have a look at Holisticon, there are some URLs. Jan, me, Axon Framework. Do we have any questions?
This is a nice summary. Jan, me, Axon Framework.
Yeah, it should be Axon Framework. Jan, me, maybe. So thank you for listening.